Okay, so we're on day 2 of 6-1. So we're going to talk about slope fields. Well, a slope field, each line segment has the same slope as the solution of the curve through that point. So a slope field, I wish I had a good picture and I was trying to find one. A slope field, it's a bunch of lines.
There was one and another one.
It's a bunch of little slopes. Can you tell what direction this graph is going?
Yeah.
Up.
Up. So if I change the C, would the graph change?
Yeah.
Yes. Okay. So the purpose of a slope field is to show the general shape of all the solutions you can, so it's helpful for getting a visual or perspective of the direction of the solution of the differential equation. So a slope field is a picture of the general solutions. Does it make sense? So if I want a particular solution, that would be through one particular point, like this point right here. So the graph would look something like this. Is this an exact science?
Yes.
No. Are they rather annoying? Yes. They are annoying to make. I do not like to make them. You would think as much as I don't like to make them, I would learn how to make them on my calculator. But I've never attempted to make one on my calculator. I have found websites before that make them, and they're fine. I guess I should probably be helpful to you and find a nice place that will make them, because they are not practical to make. They are not in a time, in time, they are not practical to make, because if this graph is only, let's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So that is 16 times 4 is 464 points plus 1, 2, 3, 1, 2, 3, plus 16, another 16. You are talking 80 points. So what I'm saying is you have to calculate 80 slopes. Is that time efficient?
Yes.
Not at all. Not at all. You will construct a small slope field today. Maybe 1 or 2 problems, they will have you construct a slope field and meet a curve, an approximate curve. If you want to take the time to figure out how to do that on your calculator or using Desmos or using other sort of means, do it and come and share with it Monday, and that can be yours. Got it? But you need to understand what goes into it. On your test, you have to construct a small slope field. Not a large one, a small one. So it says sketch the slope field of the differential equation y prime equals x minus y for the points negative 1, 1, 0, 1, 1, 0, 1, 1. Excuse me. So the first thing we do is make a chart. The charts and I don't know why I'm making it so large. Evidently, I felt the need to. Poorly constructed music trouble. Nothing. Okay, so on these, we have x, we have y, and we have y prime, which is the same as what?
Do I ever get
The slope
Slope.
at a certain point.
So the equation we're using is the differential equation they give you, whatever it may be, and the x and y. So we're going to have negative 1, 1. We're going to have 0, 1, and we're going to have 1, 1. Now, when I've constructed them in the past, the book always does one like this. I honestly take and do this. And on the top, I put my x's, and then I put my y's. And so I go like -1, actually -2, -1, 0, 1, 2. and then -2, -1, 0, 1, 2, and I do it like a multiplication chart. And so in here are all my slopes. Does that make sense? Because to me, it visually transfers over into a slope field much easier than just doing this big, long, obnoxious chart. Okay?
So you're
In that chart, you would not be able to take -2 times.
I would not be able to do what?
Never mind.
Where'd
Not
you get
important.
Oh, I should have come over here. Yes. They shouldn't have been right under it.
Yeah.
What's happening?
Or yeah.
I should have left a blank there. So this point would be -2, -1. This one would be -2, 0, -2, 1, -2, 2. Just see how that works? So when we make them, this is what I will show you, like as we go further. This is the kind of format we will be using, but the textbook puts it in this kind of format, the red. Okay, so when I plug in -1 and 1, what is my slope?
What?
-2. Into this equation, if I plug in -1 and 1, I get -2. When I plug 0 and 1, I get what? -1. And 1 and 1, I get 0. So how that would work is you would draw a coordinate plane.
What'd you put these into?
This equation.
Why?
Okay, so you have this coordinate plane. And at -1, 1. So -1, 1, right there at that dot, you have a -2 slope. So you have to picture like a little graph in your graph. Does that make sense? So -2 slope, I'm saying, oh, it'll look like this, like that. Well, at 0, 1, it's a -1 slope. So that's kind of at a 45-degree angle, yes? Do you see the difference between -2 and -1? Yeah. I mean, can you see the difference in the way my line slants? Yeah. But could you look at that and go, ooh, that's a -2 slope? No.
Probably not.
You probably could look at one and say it's a 1 slope. And what does a 0 slope look like?
Nothing. Flat line.
It looks like a flat line. So those are only 3 points of a slope field. Could that tell you what something looks like? No.
No.
In order to say what something really looks like, I would need to plug it into something like my table that I made over here. We're not going to graph them all, but I want to show you how that's going to work for us. So the ones we already have are what? -1, 1 was -2. And 0, 1 was -1. And 1, 1 was 0. So if I had -2, -1, what would my equation be? -2 for the x. Is this going to throw you off? See, I liked how I had them written. X is on the top, y is on the bottom, or side. So -2x, -1y, what is my slope? -1?
Yeah.
Okay, so -1x, -1y, what's my slope? Okay, 0x, -1y.
1.
And then 1, -1.
2.
And 2, -1.
3.
Filling in the chart's not bad, is it? What's going to be bad?
Plotting all of those.
Plotting all those. So -1, 0 would give me what? Or -2, 0 would give me -2. Do you want to go across or down? I'm going to go down. I don't know. What do you guys want to do? Cross or down?
Just go down.
Okay. So -2, 1 would be -1. No, negative 3.
Negative 3.
And then 2, negative 2, negative 2 would be negative 4.
I think it goes 1, 2, 3, 4.
Okay, and then negative 1, 0 would be negative 1. Negative 1, negative 2, or negative 2, 2, which would be negative 2, would be negative
Whole thing's negative
3. 0, 0. Oh, that one's hard. Negative 2. 1. Negative 1. 2. And 1 and 0. So to me, like I said, my brain sees this easier to transition from here to here. Does that make sense?
Yeah.
And then you would just plot all those little slopes on this coordinate plane. Do I need to do some of those, or are you good with it? Now, what I struggle with, and the reason why I think I hate them so much, is how am I supposed to tell the difference when I'm dealing with this little teeny space, the difference between a 1, a 2, and a 3 slope. 1 I know is a 45-degree angle. We should be able to tell what's a 1, right? But when I try to go to 2 and 3, then I'm all of a sudden at 8, and then I'm like at a vertical line. Well, I know 8 isn't vertical, is it? No.
It's not.
It's not vertical, but it looks vertical just because I'm dealing with this little teeny space. Okay? Natalie, why are you looking at me like I'm
understanding it now.
Okay.
For a second I wasn't.
Okay, are we good now?
I hope so.
Do you want to see some of these more graphed?
Go ahead. I got it.
How about we just look at them? How about that? Okay. That's what they should look like. Those are all teeny little slopes. Do you see the graphs? Do you see the shapes?
Yes.
Okay. So we need to match what we have to what is there. No, there's different ways people do it. You know you're going to get slopes, right? So I have some people will say, okay, well, this is 1 here, and this is 1 here. So at 1, 1, it looks like my slope is 1. Or they'll say, oh, well, right here at 0, 1, that slope is 0, isn't it? Or at 0, 2, is the slope 0?
0, 2, 0.
Isn't it 0 here? Here? Like it's 0 right there everywhere? Okay. So they say, well, that point is 0, 1. So I plugged in a 0 and a 1, and I got, okay. In this case, I would get 1. I wouldn't get 0. So there's a problem there, right? So is it that one? No. So if I plugged in, because if I had 0, 1 plus 1, I'd have 1. I wouldn't have 0. So it's not A, is it? Okay, so over here, I got y prime equals x, which would be 0, okay? Now on the next one, I've got y prime equals y, which would be 1. Is that a slope of 1? No. So A has to go with 2. See how that's working? You could use different points. You could use the ones that look like they're 1. But again, if this looks like a 1, then that must be a 2 and that must be a 3. But are we sure? Is it pretty obvious what's a 0? Yeah. So those are the ones I try to find first. So on B, is there a place we could find 0? Or undefined? What would undefined look like? It would be a vertical line, wouldn't it? Okay. But none of these are equations would give me undefined. That's not going to help me out, is it?
No.
Okay.
The 0 in the top corner.
Up here, so negative 2, this one right here,
Yeah, -2.
negative 2, 2, so we should get 0.
I hope so.
So which one would give me 0 if I did negative 2, 2? Negative 2 plus 2, so that would be I.
So the other one must be I.
Well, you can tell.
Well, yeah, but let's, okay, so we have y prime equals y, so the slope should equal whatever the y is, yes? So is there a 0?
Yeah,
Where?
along the x-axis.
Oh, they are. It's hard to see, but are they all zeros?
You should just know
So
that-
is y 0 there? Yes. Okay, now what if I asked you, so we can match these, right? So what if I asked you for a particular solution that went through 1, 2?
Well, I asked which, okay, back on that one.
Okay, so there's 1, 2, yes? So a particular solution that went through 1, 2 probably would look like something like that.
That's just 1, 1.
That is one.
Oh, sorry. That point.
But yes,
Okay, do you see how that works? Now, is it going to go exactly on every single one of those dashes? No. No. But is it going to go through that point?
Hopefully.
So let's, like if I had one here. If I'm looking at that graph, it's probably going something like that, isn't it?
Probably.
But if I moved the point over here, would it look different?
Yeah.
you going.
Yeah. It would have started somewhere over here and gone
Loop-de-loop.
like that. Do you see how these are beneficial? It allows you to see a bunch of general solutions at one time without having to put some concrete line to it. Okay. Now, again, are these exact? No, they are approximations. So different things you're going to do today. They're going to give you a slope field and they're going to say sketch a point through that. Like what I just did. They're going to say match them. Now, I would say don't sit there and write like the whole slope field on your paper. Put the point and kind of just draw what you think the curve would look like. Got it? No exact things going on here. On your test, I will actually have the slope field there and you'll just draw on it. Don't draw on your book, obviously.
Line.
Sketching a solution using slope fields. Do you need to go through the process of sketching a slope field again? That's all this is.
Not what we just did last time.
That was the big grid.
I don't want to.
You don't, I don't want to either. Autumn's like, I don't either. Okay, so if we can, if you need to. But anyone going there? Anyone need one? Natalie, you do know that y prime is the slope, yes?
I'll make a note.
So, this is my thing. For your slope field, you have to go from -2 to 2. On both the x and y. Got it?
What do you?
Does that make sense, what I'm saying? So, -2, -1, 0, 1, 2. And then -2, -1,
21 degrees.
-2, sorry. -1, 0, 1, 2. If you look at it the way I had in my brain, this is my y-axis. Yes?
In the.
This is my, no, I'm sorry, this isn't, well, depending which one you put X or Y on. It would probably make sense to make these your X's and these your Y's.
Why'd you do 2 to 2? Or negative
that's
2
what
to
she
2?
said.
Because I just said -2 to 2.
Just for fun.
No.
Well, because if you only have 3, is it going to give you any picture of what you have?
Oh, I
Yeah,
thought you
no,
just
really,
did it
it's like-
through 1 to 1. 1, column 1.
No. What it says is sketch a slope field. So this would be my slope field. And then what passes through 1, 1. So
You use
right
the
there's a
slope
point,
sketch.
and then you sketch the graph through that point.
Oh.
Like what here. There's a slope field, and then sketch a graph through 1, 1. Right there.
Okay.
Got it now?
Now I do.
Okay. So your slope fields, now there's a lot of slopes in that, even just from 2 to -2, isn't there?
Yeah.
I think you only have 1 or 2 to sketch, I'm pretty sure. I hope I didn't give you, if I gave you more than 2, don't do more than 2.
Don't worry, I won't even do this.
They do have a place. I was pretty picky on your homework today. So, you are 6'1", page 411, 31, 33, 37 through 55 odd. And 57 through 64. I think the 57 through 64 are the matching.
That's good. I like
That would seem something like I would do to make all of them. I think it's funny when you look in books and they say